Hi, I'm Alex from Tailscale and welcome into part 3 of our Infrastructure as Code playlist. In part 1, we covered Cloud Init. That's a technology that lets you configure a completely blank virtual machine just by providing a few lines of text. You can do things like create users, configure the network, install packages, but it has its limitations. In part 2, we took Cloud Init a step further and automated the creation of a cloud resource, in our case a DigitalOcean droplet, using Terraform. Terraform's great for creating infrastructure, but it's not so hot at actually configuring the nuts and bolts of those virtual machines and some of the other stuff that Ansible can do. So that's what we're going to do in part 3 today. We're going to use Ansible to configure that blank virtual machine that we created using Terraform. Back when I was a fledgling university student, Ansible was one of the very first DevOps technologies that I ever learned. And indeed, I still believe today that Ansible is one of those foundational DevOps technologies that is fundamental in the day-to-day life of an infrastructure engineer. It's one of the most approachable technologies in the space as it uses simple YAML configuration syntax to describe exactly what it's doing. In the infrastructure as code world, we love to declaratively describe our systems, and Ansible lets us do just that. We define a series of tasks in a specific order and group those tasks together into playbooks. Those playbooks get executed against remote systems, and we bring them in line by doing so with our desired state of the world. I should also add you can run Ansible against your local system, and in fact I know many folks who use that as a learning opportunity when they're first getting started with Ansible. So let's take a moment and just look at what Ansible is in its most simple form. Really, it's just a way to configure systems. It does this by taking a series of inputs, YAML files with variables and tasks, and it gathers a bunch of facts about a remote system and ensures that there isn't a delta between these two states. It connects to these remote systems via SSH in what's called a push model, so it pushes its configuration to a remote host. This is in contrast to a tool like Puppet, which is running on a pull model. So it has an agent running on the remote host, phoning home and asking for configuration changes. So what this means in practice is that you must be able to connect from your Ansible control system to push the configuration out to the system that you want to remotely configure via SSH. So this is where Tailscale comes in. We already added our remote system to our tailnet using Cloud Init in parts 1 and 2 of this video series, and in doing so, we removed that initial dance of creating a bootstrap SSH key, creating a temporary bootstrap user, and all that kind of stuff. Simply by virtue of being on our tailnet, Tailscale is able to provide your identity to the remote system's SSH service to validate it's you and let you in. Now, because Ansible connects via SSH, remember, so long as we use a Tailscale node name to connect, we never need to worry about SSH keys ever again. It's really cool, and I'll show you this later in the video. Ansible is written in Python, but we don't need to know any Python to use it. In fact, all we need to know is how to use the Ansible module system. So there's a huge long list, as you can see on the screen right here. Things from line in file, so if you want to modify just 1 or 2 characters in a specific file or change a value, you can do it that way. There's a file copy module if you want to copy files to the remote host. There's packages, there's user modules, honestly, there are so many modules for Ansible, not just for Linux systems, but for networking appliances and all sorts of other stuff as well. It's kind of overwhelming to start with. But in reality, you're only ever going to need a handful of modules to get started. But where I really found it most useful was managing configuration files using the Ginger templating language. Now, of course, your mileage may vary. You might want to just use Ansible to install a few packages and create a few users that you didn't do in the previous Cloud Init configuration. Or maybe you want to bring a virtual machine up to some policy inside your organization, or whatever you want to do with it. Ansible's a fantastic tool that executes a bunch of tasks in a sequential order. It's almost like a bash script, but a bash script that's actually smart. One of the separating things between just a bash script and Ansible is this concept of something called idempotency. An idempotency is something that is contextually aware of what the target host is going to be doing. So from my laptop here, I will run an Ansible command. I'll run what's called a playbook, which is a series of tasks in a specific order against a certain remote host. Ansible is smart enough to gather a bunch of facts and a bunch of information about that remote host and decide whether it needs to execute a certain task or not. So it's not going to go ahead and install 20 copies of the same package over and over again, for example. It knows I've already got Git installed on this computer. Well, I don't need to go and install Git again. I've already got it. But there's a bunch of other configuration flags you can pass to Ansible as well to actually update those packages. So if you wanted to, say, just verify that something is present on the system, you can do that. Or if you'd like to say, give me the latest version of something, you can do that too. And every single Ansible module has this concept of configuration flags that you pass to it at runtime. Ansible is configured using the YAML, I don't want to say programming language because that's going to upset a few people, but I mean, essentially at this point, YAML, particularly once you get into the Kubernetes space, it kind of is a programming language at this point, and we do make it do things that perhaps it possibly shouldn't. But essentially what we do with YAML is we specify each module we want to run, and then the parameters, and then the Python code that Ansible executes under the hood, which we don't actually see. Ansible's written in Python, but we never have to write any Python, unless you want to get into custom filters, but that's way beyond the scope of today's video. What you want to do is just write these YAML playbooks, which execute a certain set of tasks in a specific order, as I say, against a remote host. So what we're going to do today is I have the Terraform code linked in a description down below, along with all the Ansible code and everything I'm going to show you in today's video too. So what I'm going to do is just jump over here to my tailnet. Now you can see that I have a machine over here called Fake NAS. And on Fake NAS, I'm running a Jellyfin server. I've got to get my Michael Portillo in every now and again. Something comforting about Great British Railway Journeys. It's one of my favorite go-to comfort food TVs. Anyway, I digress. So what I want to do is take this Jellyfin instance, which is currently running on Fake NAS port 2285, and expose that to the public internet. Now I could do this using Tailscale funnel, but it's probably a bad idea because of some of the quality of service stuff for streaming video specifically. Same is true with something like Cloudflare tunnels. I mean, they have a specific line, I think, in their terms of service that say, please don't stream video via this. It's not what it's meant for. So if we want to actually go ahead and configure something to stream video, we probably want to spin up a VPS. Well, that's what we're going to do today. We're going to spin up a VPS on DigitalOcean using the Terraform and Cloud Init code that we already showed you in parts 1 and 2. And then we're going to use Ansible to configure Caddy, which is a reverse proxy. Now, all a reverse proxy does is it sits out on the public internet and waits for somebody to connect to a certain URL. In our case, it's going to be jellyfin.something.com. It then takes that request and tunnels it back to my server that's running in my LAN safely over a Tailscale encrypted tunnel. Now, if you think about the ramifications of what this means, you can have one VPS reverse proxying any node and any service on your tailnet anywhere in the world. It's an incredibly powerful realization once you have it. Okay, let's jump in. In my VS Code instance over here, I have a couple of folders, and again, link in the description down below to all this code. But I have an Ansible directory here, which has a few files in it. And if you're brand new to Ansible, I'm going to go through everything step by step, and there'll be chapters if you want to skip past a certain piece. So bear with me. Okay, so first of all, we are going to look at this Ansible config file here. This is just a bunch of Ansible specific stuff. If you are new, don't worry too much about it. Essentially, it's just configuring a bunch of stuff like where the hosts file lives, where the encryption password lives for our Vault password file, that kind of stuff. And also where we import any third-party roles that we're going to use. So remember when I was talking about how Ansible is a bunch of tasks that get executed in a specific order? Well, that grouping of tasks is called a role. And the idea would be that you have a web server and you want to configure a bunch of different roles. You want it to have a certain set of packages, a certain set of users, and in our case, a certain reverse proxy configuration. Well, you'd give it a role that configures the server to perform that role. The grouping of roles, so you can have multiple roles. So you've got, it's a little bit confusing. You've got a grouping of multiple tasks is a role, and then a grouping of multiple roles is called a playbook. And the playbook gets executed in a specific order. Now, the playbook we're going to run today is this run.yaml playbook, and currently there's only one role in it. It's going to run against this host, which is nyc terraform caddy, and then there is a secrets YAML file that lives over here in vars/secrets.yaml. This role is configured in the requirements.yaml over here, Now, Ansible has the concept a bit like Docker Hub, where you can import third-party roles and repos and that kind of thing. So all I'm doing here is specifying that I want this Git repo, Ironic Badger Ansible role caddy, to appear as ironicbadger.caddy in my playbook. So that's where that code comes from here. And to install that role, what we need to do is an Ansible Galaxy install. There is a just file, which if you've ever worked in infrastructure roles, you might see make files or scripts to do a bunch of commands. I'm using this one called just, which is, I think, on GitHub by Casey/just, if you want to Google it. There'll be a link down below, of course. This just file here is executing this command, Ansible Galaxy install -r requirements.yaml. But all I need to do to execute that command is type just rex, and you can see that just here. These commands, this isn't Ansible specific, but it really helps you organize the commands you've got to run. You can see that sometimes they start to get a little bit long in the tooth, these commands, and there's a lot of stuff to remember in tags and hosts and yada, yada, yada. So the rex thing here is my shorthand in my mind for requirements. So when I type just rex into the terminal down below, you can see that Ansible goes out to GitHub, pulls in the latest version of that role, and installs it into this Galaxy roles directory over here. That's configured in our Ansible config directory up here. See this roles path? We can see under print working directory. So current working directory is this one, O2 Cloud Init Do Terraform. You can see that over here. That's why that gets installed to this directory here, is because of this Galaxy roles option that's right here. So you can see it created that Galaxy roles directory, and in it is now the Ironic Badger caddy role. Now, remember, a role is a grouping of tasks. So let's jump inside this role and take a very quick look at what it's going to do for us. The main.yaml is almost always where you want to start with a third-party role to try and understand what it's doing. Beyond the README, of course, which I definitely put many long hours into for this one. So under main.yaml, we can see the very first thing that this role is going to do is check to see if the caddy binary is present. This registers what's called a fact, and then Ansible uses that to decide whether to actually execute the next entire grouping of tasks. So by doing this include tasks section down here, we're able to conditionally include and decide how to, it's like an if then else statement effectively, when true by default, and obviously when this is false, I want to install caddy, and when it's true, I'm not going to. Okay. Now, when I jump into the install YAML file, what we're going to do is download the latest release of caddy, add the users, add the groups, make sure that the systemd service gets installed, and then call the systemd module. Now, if this is the first time you've ever seen an Ansible playbook, forgive me for rushing through that a little bit. Let me just explain what's going on here. This is the structure of how an Ansible module always works. So we are using YAML, of course, and each block here is defined by this little dash at the beginning. And what we do for good practice is we give each task that happens here a name, and then we call the module. So in this case, this is the get URL module. Now, if we want to look up the documentation for that specific module, we can go to Google and type in Ansible and then the name of the module. And over here on the Ansible website is a bunch of information about how to actually use and configure this specific module. Right at the bottom, I never know why this isn't at the top, but whatever, it's always at the bottom. You can see there are a bunch of examples of how to actually use this specific module. So I noticed there's a small typo in my code. It's not really a typo because a few years ago, Ansible introduced the idea of collections. That's a topic for an entirely separate video. What we're going to do is just use the Ansible built-in module of get URL to fetch the caddy binary. This is the reverse proxy, remember, caddy, and install it into a specific destination or path on our host system. Now, where are these variables defined? So if we look at the parameters that are configured in this module, in this task right here, we can see we've got two things being substituted in and out. So we've got the caddy AMD64 Linux binary URL. This is where the caddy project published a Cloudflare compatible version of caddy. If you want to use caddy with any other providers like Cloudflare or DuckDNS or Porkbun or Namecheap or whoever, you need to download the specific version of caddy for those DNS providers for the DNS challenge to work properly and get your TLS certificate. In my case, I'm doing everything with Cloudflare today. So if I look in the defaults folder over here, we can take a quick look and see that the Linux binary URL includes the caddy DNS Cloudflare plugin. This is all open source. All this code is in GitHub, and there'll be links to it down in the description down below. The next thing that gets included is the caddy binary path. So if we take a quick look at the install page again, we can see the destination. This is where it's going to actually install that binary, and then it's going to make it executable and owned by root and also by the group root. And so it continues throughout this file. You can see we create the group, we create the user, we create the systemd service. Now, this is a really interesting one. Remember I talked about Ginger templating? This is where it starts to get really pretty cool, in my opinion, as a massive nerd. So if we take a quick look at line 22, we can see we're calling the template module. Now, if we go back to the Ansible documentation and have a quick look at the template module, you can see there's a bunch of other stuff that we can do with this module. But one of my favorite things to do is sometimes just to use it to configure some very basic parameters. So what it's going to do is it's going to take this caddy.service.j2, Ginger2 file from the templates directory and install it into /etc systemd system caddy.service. So let's take a very quick look at the systemd unit file that's going to be installed. And you'll notice there are some variables here. So in the main, this is such a confusing thing about Ansible, but in the main file, you need to use these quote marks and the double curly braces to have a variable substituted by Ansible. But in a downstream Ginger2 substitution, because of the interpreter that Ginger2 uses versus the Ansible Python interpreter, it's all about string quoting, and honestly, very confusing. It's just one of those things you have to learn. And once you get it, you're like, okay, that makes sort of kind of sense. In the Ginger2 file, you notice there are no quotation marks. So I should put these two side by side real quick. You can see that the caddy user here is in quotes, but in the actual Ginger2 file, it isn't. It's not a mistake. That is just the way it's supposed to be. Now, here we've also got the exec start and the exec reload. This is pointing at the specific binary path where caddy's binary got installed to by the previous task in the playbook. And then that's it. The caddy binary is installed and the systemd service is also installed. But at this point, it doesn't have a configuration. So what we need to do is actually install that configuration. If we jump back to our main.yaml file, we can see we've got a bunch of tasks here that get executed in order. The last one is configure. So taking a look at configure, you can see the first task here just essentially makes sure that the target directory for the configuration file exists, which is the caddy file path, which gets defined in the defaults file over here. Caddy file path in this case is /etc/caddy. Now back to the configure YAML file over here, we're going to write out the caddy file. And if you are a Ginger nerd like I am, you're going to love this. So take a quick look at the caddy file right here. We can do loops. We can do for loops. We can iterate over this file and start doing all sorts of ifs and fors, and it's really cool. So what we're going to do now is provide the Ginger templating module that Ansible is calling with a bunch of variables. And we're going to present these in this folder here called group vars. So take a quick look at this caddy file here. This is a list of dictionaries in YAML parlance. And you can see here that each grouping is again denoted by this little hash, this little line at the beginning of the grouping of dictionary within YAML. Under this data structure here of caddy underscore endpoints, we can see we've got a bunch of information. So friendly name, fully qualified domain name, upstream, TLS insecure, provider, etc. Okay, so let's step through the templating process that's going to happen with Ginger. On the left hand side, we can see that if caddy TLS providers is defined, well, up here, yes, it is defined. For item in this list of dictionaries, what I want to do is iterate over each group. So I could have multiple providers here, for example, if I wanted to. Remember, caddy itself only supports Cloudflare for now with how the role is configured, but this is an exercise for the reader if they want to configure it themselves. So taking a quick look at this dictionary here, we can see we've now got two dictionaries within inside this list. Okay, I'm going to go back to one because we don't need to, because they'll be the same. We're going to iterate. So for item in caddy TLS providers, we're going to take each item from each provider. So item.provider now is referring to the value Cloudflare. But essentially what it's going to do is just output a caddy file formatted in the way that caddy is expecting to call a DNS challenge. So we need to provide a few things to do that. And one of them is an API token. And this really is the magic of why I love this method so much. I've used it for my Docker Compose files for years at this point, 6 or 7 years at this point. And I love to roll this out whenever I can and show this off to people, because I just think it's the coolest implementation of taking a plain text secret and actually making it somewhat secure and being able to commit it to source control. So this value here of Cloudflare API token actually gets stored on disk as an encrypted value. So under this vars directory here, remember, I'm going right back to the beginning now. So just bear with me on the directory structure. On the left-hand side where it says run.yaml, remember we configured this secrets.yaml to be pulled in at runtime? This is what that file looks like right now. So you can see there are 2 tokens here. We've got an API token. Well, actually, it should only be 1. I think that was me testing earlier. So we've got 1 token here, okay? Just 1. And in this Cloudflare API token is the value that I generated in my Cloudflare dashboard. So let me show you how I did that real quick, just so you have it on record. Get logged in to your Cloudflare dashboard, make sure your domain is activated and registered, and then go over to your account where it says My Profile up in the top right-hand corner and click on API tokens. Next, we want to just go over and make sure we've got this specific thing configured. So if we go to the summary, we want to make sure we've got the following things enabled: zone read and DNS edit. Now I'm going to roll this token just so that I get a fresh one for this video. Now I'm going to paste that in and we should be good to go. Now remember how I'm using just as an aide memoir for all of my various commands. One of the things that's in my just file is a way to encrypt this value. So there is a vault option down here on line 22. So what I can do is do just vault encrypt. What that's going to do is call Ansible Vault's encryption tool to encrypt this file. It's going to do that using a password that's configured in Ansible config. So ansible.config over here has a file for the vault password file at .vault password. Now this is such a secure password. Oh my goodness. I don't know how anybody's going to break that with a quantum computer, but the idea is, rather than me typing it on the command line, this happens automatically. And this kind of detail is really important when you want to start using Ansible in a CI environment. Okay, so I'm going to do just vault encrypt, and you'll see that underneath now, my secrets file, this happens in real time, by the way. If I type decrypt now, you'll see that it's now decrypted, and I'm going to just encrypt it again. And voila. We now have a completely safe, well, apart from the fact the password's kind of rubbish, we have a completely safe file that we can commit to source control here. And so this means we can provide sensitive information securely, or at least relatively securely, because it still ends up in plain text on the disk of the remote host, remember, but it's not going to end up in source control on the public internet as a clear text secret, at least. This is now going to be substituted into our caddy file using the Ansible Ginger 2 templating engine. So let's jump back to the configure tasks that are happening and just take another look at the caddy file that's being configured right here. So we've jumped through the first few hoops. We've got our provider configured. This is what's going to tell caddy how to actually talk to Cloudflare and configure the DNS challenge side of getting our TLS certificate. And then the final part here is the caddy endpoints. This is where it's going to loop over the list of dictionaries defined in my group vars. So in this specific role, I've only got one host configured, but I could very easily configure 2, 3, 4, 20, 1,000 different hosts to be reverse proxied by this instance. And all I would have to do is add these 3 or 4 lines here, and you could probably make this a lot cleaner if you're so inclined, but I didn't think 4 or 5 lines was too bad. So the idea is that once this is done, we run one command against our remote host and our caddy file gets configured, caddy gets started, and the systemd service also gets started. In that process, caddy will handle the automated TLS of getting us a Let's Encrypt certificate for our own custom domain. We're not relying on ts.net here or Cloudflare tunnels, as I mentioned, or any other kind of proxying. It's just connecting the caddy reverse proxy over Tailscale with a direct connection, almost certainly, back to your local instance of Jellyfin running in your house, in my basement, in my case. So let's go ahead and actually configure and show you how this is doing. I'm going to try and upset the demo gods right now and do this in real time. I don't know what I'm thinking, but here we go. So what I want to do is, to start with, I'm going to use my just file to actually create the Terraform resource, which in my case is a DigitalOcean droplet. Now, you can see that already this virtual machine is being created in front of our very eyes. Once that's created and we have an IP address, a public IP address for this host, we do need to create the DNS record in Cloudflare so that when you're out and about on the public internet, you can actually resolve the reverse proxy. You're not exposing, well, you are kind of exposing your LAN to the internet, but not directly. It's all over Tailscale once it gets to the reverse proxy. But you are putting this on the public internet in so much as that this domain name will be routable from anybody anywhere on the internet. So just bear that in mind. Set up some firewall rules to geo-block certain countries you're not in. So once I have this IP address, I'm just going to copy this into my Cloudflare DNS profile for my domain. So the Cloudflare dashboard always confuses me a little bit, but over here on the right-hand side, I've got initechlabs.dev. And then on the left-hand side, I've got my DNS records over here. I'm just going to add a very simple A record. I'm then going to give it a name, in my case of JF for Jellyfin. And then I'm going to give it the IPv4 address of the DigitalOcean droplet. I'm going to uncheck the proxy status thing because I don't want Cloudflare proxying all of my video traffic in this case. And then I'm going to click save. Now this DNS piece potentially is the bit that will take the longest to propagate. So what I want to do whilst that's propagating is just check that the VM got added to my tailnet correctly. I'm going to jump into my Tailscale machines page and hey, look at that. NYC1 Terraform Caddy is now on my tailnet. I'm going to click on the SSH button because I also enable SSH. Change the username to Zaphod, and this is going to open a brand new SSH session in the browser, by the way. You don't need to use a terminal sometimes. And I'm just going to connect to the console of this virtual machine over Tailscale SSH with a quick ephemeral session that we set up in the browser. Voila, there we go. Look at that. Isn't that fantastic? And you can even see in the background that the SSH console is ephemeral. So that means once I disconnect, it's going to automatically remove itself from my tailnet. So this just proves to me that Tailscale SSH is working exactly as it should. The virtual machine is up and stable, and it's been up for 2 minutes. Okay, so now it is time to go ahead and actually try and run the Ansible role against this machine. So we can see that Terraform completed successfully. We know that our machine is on Tailscale SSH. It's on our tailnet. All right, demo gods, be kind to me. I'm going to do just run caddy. Remember, I already did the just rex to get the prerequisites. If you forget what that looks like, just rex looks like this. That installs the caddy role from GitHub. That I wrote to configure my caddy virtual machine. I've got my fully qualified domain name here of jf.initechlabs.dev, proxying to the upstream location of fakenaz:2285. So it really is time to actually run the Ansible now. So I'm going to do just run caddy, which is, if we take a quick look at my just file over here, just run is the shorthand for Ansible playbook -b for become or root user, and then we're going to run the run.yaml playbook and limit it to a specific host, which in my case is caddy. Now, I didn't talk you through the hosts file. I really should do that before I press go. If we look at the hosts file, this is where it starts to get pretty interesting. So there's a few things going on here that you need to be aware of. First of all, line 1, this is the grouping of hosts. Now, I could have multiple hosts here. I could have NYC2, which I think Copilot was trying to do for me. Yes, there we go. You know, I could have multiple hosts in here. I could have, you know, web servers. I could have, you know, web 1. I could have a database, right? That's the idea of these groups, is you can start to group hosts in specific groups. And then you can use group vars to apply specific variables to all of those hosts that live within a specific group. I ran into some weirdness with host vars a few years ago. I can't remember the specifics, but I always just use group vars, and then I put maybe one host in that specific group, and it works for me. So up to you. Your mileage may vary. If you get confused reading the documentation about host vars versus group vars, just tell them Alex sent you, and then it'll all be fine. Okay, hand wave time. So the next thing we need to look at is the host name or the IP address that we're connecting to. In our case, NYC1 Terraform Caddy is the DNS host name that gets applied to that specific host by Tailscale. So if we take a quick look at the addresses that are here, we could, if we wanted to, substitute this for the fully qualified domain name of our tailnet if we want to get really fancy, but this is going to work just fine as well. This could also be the public IP address of the server if you have SSH keys installed manually, but we don't. I didn't install any SSH keys for this Zaphod user. I'm simply relying on the Tailscale tailnet just by virtue of being on my tailnet for authentication with the remote node to say, hey, this is definitely Alex. You can allow him to SSH into this node as a Zaphod user. So in order for Tailscale SSH to work, and in order for this whole thing to work, this name here must match the name that's in your Tailscale admin console. All right, and with all of that said, it's time to actually push go. At the bottom here, I'm going to type just run caddy at last. And if this is the first time you've ever seen Ansible's output, it can seem a little daunting sometimes with all these stars going across the screen and stuff. But if you actually take a moment to look at it, we're just running stuff we've looked through in the code manually. We're running the is caddy binary present check, and then we're installing caddy and including certain files and installing systemd service. We're not doing anything that isn't already named in the playbooks and the roles and the tasks once we get right and drill right down into it. And you can see that we've finally actually gotten to the point where caddy is installed and configured. At least I hope so anyway. So now it's time to SSH into that host as Zaphod. So again, we can use Tailscale SSH to SSH into that remote host. And hopefully if I do a systemctl status caddy, we can see that caddy is running. And again, even more hopefully, this is all happening in real time, we can do jf.initech.labs.dev. Oh, please work. Hooray. It actually seems to have worked first time in a demo. That's actually a first for me. Okay, cool. There was not even any movie magic going on about this demo for once. So what we can see now is that my Jellyfin is now on the public internet with a TLS certificate on a domain that I own using nothing but Cloud Init, Terraform, and Ansible. How easy was that? There's so much technology gone into what you've just seen there. And I'm aware that that took a long time to explain on video. But the reality is we could actually destroy this virtual machine and spin it up in under 5 minutes and get this caddy stuff configured automatically. So let's say hypothetically, you travel for work, I don't know, a few times a year. You don't necessarily need to access your Jellyfin all the time. But when you're away from the house, maybe you want to. So you could set this up as a GitHub action or have some kind of Home Assistant automation that would configure and start off some CI jobs somewhere to deploy this reverse proxy automatically in less than 5 minutes, using Cloud Init to automatically add it to your tailnet, and then using Terraform to automatically provision that infrastructure on DigitalOcean. You could even take that a step further and add the DNS record automatically using Terraform, or actually you could probably do that using Ansible, as it has modules for almost everything in the entire known universe as well. So, and then finally, you can configure the caddy reverse proxy using Ansible automatically as well. And remember that this caddy node is just another node on your tailnet. So I'm going to just jump back to the console of this DigitalOcean droplet right here and do a Tailscale status just to kind of hammer it home for you. This laptop right here is the one I'm using to record this video. It's behind a residential firewall. There are no ports open. There's no, UPnP or whatever that's going on that games consoles like to try and punch through firewalls with. This is all happening over what Tailscale calls NAT traversal. So if I do Tailscale ping and then put in the name of MBP Baldrick, which is the name of this computer, you can see I've got a direct connection. It's not even going through a bounce server, which we call a derp server, a relay proxy. This is just a direct connection from that host where caddy is running in the cloud straight back to this local laptop. Direct connection. There's no middleman whatsoever. So you could start spinning up stuff at friends' houses, parents' houses, if you have the joy of having colo in your life or a co-located server or something, that too. Firewalls become kind of invisible with Tailscale, and that really is one of the magical parts of using it. And then when you're done, of course, we are just using infrastructure as code. It's just one command to clean it all up again. If I type just destroy, it's going to do the Terraform thing of saying, are you sure you want to do this? And if I go back to my web browser and back to DigitalOcean, in just a few seconds, we'll see the NYC1 Terraform caddy disappears, ceases to be, becomes an X parrot, a droplet, I mean. There you go, it's gone. So in the background, you can see Terraform still doing its thing, but so far as DO is concerned, the node is gone. Now you'll also notice that on our tailnet as well, that this is an ephemeral node. So because I set ephemeral when I generated my auth key, which I covered in part 2, but I'll just show you real quick just in case you got this far. Settings, keys, and then generate auth key over here. I set this to be ephemeral. And what that means is that when the device is removed from my tailnet and goes offline, eventually after a few minutes, Tailscale will automatically go ahead and clean up those ephemeral nodes on the regular for you. So I'm not sure if this will be the end of the Infrastructure as Code playlist forever, but it's certainly the end for right now. We've looked at 3 really core DevOps technologies in the last few weeks: Cloud Init, Terraform, and Ansible. If there's another technology that you would love to hear about and how you could use it with Tailscale, maybe something like Pulumi, or you want to see this with a different cloud provider, maybe AWS, or I don't know who you guys are using. Let me know in the comments down below. So I hope you found today's video useful, and I hope I introduced a few of you to some new concepts, and of course, introduced some of you to Michael Portillo and his Great British Railway journeys. Mwah, they are fantastic. Until next time, thank you so much for watching. I've been Alex from Tailscale.